Hi, welcome to another mini lecture. Topic today is solving an equation involving logarithms on both sides, type 1, or here we have type 2. And the difference is one of them has 2 logarithms in it and the other one has 3 logarithms in it, and so on. Same idea. Okay, so what does it look like? We have an equation. There are several logarithms in this equation. How do we approach this type of a problem? Uh, Remember, a while back we had writing an expression with a single logarithm. That's the general idea applicable to all of these problems. So what we have to do is to collect all the terms and write it as a single logarithm. Then we'll be able to handle the problem. What does that mean? Well, here I have a logarithm here, another logarithm here. I want to combine them into a single one, but they better be on the same sides for the combination to work. So logarithm of 5 of x plus 6, I take this thing to the other side or add that expression to both sides. So I'll have logarithm of x plus 2 in base 5, and that is equal to 1. Okay, so first we rearranged so that the logarithms and x's are on the same side. Next, I say, do you remember that logarithm of a plus logarithm of b was logarithm of ab? It could be any base so long as they're all the same base. So I can take this thing and write it as a logarithm of this expression. This is my a, this is my a, this is my b, and I'm writing x plus 6 and x plus 2 multiplied each other in base 5 equals 1. So all of this is one single expression inside logarithm. If you want to emphasize that, okay, this is logarithm of all of this equal to 1. Well, logarithm of what number in base 5 is 1? Well, it has to be logarithm of 5. How do we write it formally? We say that number x plus 6 times x plus 2 is equal to this base raised to this exponent, which is just 5 raised to 1 is just 5. Now we are back to some basic equation you learned in high school how to do. You might as well expand this. So x times x, x squared, 6x, another 2x, and another 12 is equal to 5. So x squared plus 8x plus, subtract 5 from 12, 7 is equal to 0. How do you proceed? I'm sure you're all expert in this. So two numbers such that the product is 7 and the sum is 8. They are x plus 1 and x plus 7. So out comes two possibilities. X is equal to minus 1 and x is equal to minus 7. Now we have a new twist to our story. In these logarithm problems, generally any equation, when you come up with an answer, best advice is to go back and make sure it actually makes good sense. And I'm going to explain where something could sneak in and an incorrect answer could present itself as a correct answer. Well, what do we mean by that? Is it possible for minus 1 to be an answer? Well, go ahead and check. Put the minus 1 here, so I'll have logarithm of, in base 5 of, minus 1 plus 6. Minus 1 plus 6 is equal to 0. How do you proceed? I'm sure you're all expert in this. So two numbers such that the product is 7 and the sum is 8. They are x plus 1 and x squared. 7 is equal to 0. How do you proceed? is that, so we are checking, so put a question mark, minus logarithm of base 5 of minus 1 plus 2. Is that true? Well, let's simplify it, see if it's true or not. Minus 1 plus 6, well, that is 5. Minus 1 plus 2, that is 1. Logarithm of 1 is 0. Logarithm of 5 in base 5, well, that is 1. So the whole thing is reduced. Is it true that 1 is equal to 1 minus 0? Well, yes, of course it is. Well, what could possibly go wrong? Let's try with minus 7. If I put minus 7 in my equation, would it work? So if I have, if I have logarithm of minus 7 plus 6, is that equal to 1 minus logarithm of minus 7 plus 2? Well, no, not so. What is wrong with that? Well, here the argument of a logarithm has become minus 1, and here it's minus 5. Logarithm doesn't make sense for negative numbers. The input of a logarithm cannot be negative. So this equation doesn't make any sense because there is an ingredient here, in fact two of them, which don't make sense. Well, how does this thing sneak in? The way it sneaks in is that if we don't pay attention to this, bring them to both of them to one side and write it as the product, then one of these terms is minus 1, another one is minus 5. During this multiplication, the minuses evaporate each other, and out comes a 5 whose logarithm is 1. So it looks like we have an answer, but if you want to trace it all the way back to the beginning, the ingredients don't make sense. So this is not acceptable. So if both of them were acceptable, Alex tells you separate them by common and write it. But since one of them isn't acceptable, all that you write here is just minus 1 and you are all done. If both of them are acceptable, you separate them. When you're typing your answer, you see here it's allowing you to separate them. It says create a comma separated list of entries if there are several multiple things that are acceptable. If not, you just have one answer. Okay, so big lesson that we learned here. Number one, bring everything to one side, convert it to a single logarithm, and proceed. Second issue is that you better always check your answers, especially when you have two or more logarithms. Here is another problem similar to that. We bring logarithm to both sides, so I'll be faster on this one. I bring the logarithm base to 4 of x minus 2 is equal to 1. Perhaps in high school they go ahead and write it like this, minus logarithm 4 of x minus 2 minus logarithm of 4 of x minus 2, and then cancel these and then so on. That's all fine, but you better graduate out of that and become a bit faster. This expression goes to the other side, becomes negative. That's how we write it in university. Logarithm of something minus logarithm of something else. Logarithm of A minus logarithm of B. What was the rule? The rule is that this is a logarithm of a ratio. So I have a logarithm of x minus 5 over x minus 2 in base 4 is equal to 1. Well, logarithm of what number in base 4 is 1? Well, that's just 4. Formally, how do we write it? We say x minus 5 over x minus 2. This base raised to that exponent, which is just 4. How do we solve it? Well, cross multiply. X minus 5 is 4 times x minus 2. We multiplied. Open. X minus 5 is 4x minus 8. Subtract x from both sides, so let me write here, so that becomes 3x. Add 8 to both sides, and that becomes equal to 3, so x becomes equal to 1. And now comes the question, is this acceptable? We go back and say, well, 1 minus 5, it's minus 4. That immediately says red flag, this is not acceptable. You don't need to go any further. But if you want to see what's happening, 1 minus 5 is negative. 1 minus 2 is also negative. Those two negatives have canceled each other out, and this kind of answer has sneaked in. This is not acceptable. We don't have a second one, nothing else there, so that becomes our answer. There's no solution. Another example, we take the logarithm to both sides, so I'll have a logarithm in base 5 of x plus 3 minus logarithm base 5 of x minus 1 is equal to 1. Combine here means a ratio. The fraction that we have here has to be 5 to the power of 1, which is 5. Cross multiply, so x plus 3 is 5x minus 5, which tells us 4x is equal to minus 8, excuse me, plus 8. 4x is equal to plus 8, so x from 5x becomes 4x. Add 5 to both sides, you get an 8, so x is equal to 2. And if you check 2 plus 3, positive 5, 2 minus 1 is just 1. Nothing goes wrong in any of these logarithm expressions, so this is acceptable, and the answer that we have here is just one answer, and that is just 2. Type 2, well, minor variation on this theme. We have more than 2 logarithms, 3 of them, maybe more. How do we proceed? You might want to bring everything to one side or something like that. All the logarithm expressions better be well, let me restate. You can approach this problem multiple ways. For example, you can say logarithm of x is equal to logarithm of, combine these two, x minus 2 over 3. You could have also bring 2 of them to one side, or all of them to one side. All of them gives you the same answer. So logarithm of 2 expressions are equal. Logarithm is a one-to-one function. The only way this works is if the arguments are the same. You cross multiply, 3x is equal to x minus 2, so 2x is equal to minus 2, so x is equal to minus 1, and there is the red flag. I can't put minus 1 here. That's not going to be acceptable. There's always another one that's also not acceptable. You see, this one becomes minus 3. You cannot feed the logarithm a negative number. Even worse than square root that doesn't accept negative, logarithm objects even louder. So not acceptable. So-called extraneous solution. So again, we don't have anything here to report. Another type 2. Remember, logarithm with any base under it means logarithm base 10, but in this case it doesn't matter what logarithm you have. So logarithm of x minus 8 over 20 is equal to logarithm of 9. The only way this makes sense is the arguments have to be the same. Logarithm, you say, is a one-to-one function. The only way logarithm of something is equal to logarithm of something else is that those two things should be equal. Cross multiply, x minus 8 is equal to 180. So we have interesting answer. That the answer is 188. Okay, so we have to always watch out what is acceptable, what is not acceptable. So let me just add one more to this list of problems to you. Try to figure it out. Logarithm of x minus 9 is equal to 1 minus logarithm of x minus 12. Solve that and find out how many solutions they have and what are the numbers. Okay, so going back, we looked at equations involving logarithms, 2 or 3 of them, all types, and one thing we learned that you have to check the answer to see when you have logarithm of any expression. That's only acceptable if that expression is positive. Otherwise, the logarithm is going to be meaningless. So whatever answer you got, you have to check them in all the input fields. Make sure that no argument of logarithm becomes negative. Okay, so that we are done with this, and hopefully we'll have another one pretty soon. Until then, good luck and God bless.